The rain is coming down here in Texas, so once again, we're going to use some stock footage. That's about what it looks like outside right now. Overcast with scud and a lot of mid and upper level cloud. Situation in the tropics this afternoon looks pretty quiet. We do have Tropical Storm Nana crossing Guatemala. That's going to be heading into the area just south of Mexico, and that will be out of the picture. Omar is heading east, so we don't have to worry about that one either. But in the 5-day, things are picking up here in the southern North Atlantic. However, looking at the GFS, and it has done pretty well with these storms so far. You can see that they appear in the 1-week window around Bermuda and then recurve northeast. And elsewhere, it looks pretty quiet down there in the Gulf. In fact, the main factor in the U.S. is going to be cold air, driving drier conditions, milder weather into much of the eastern two-thirds of the U.S. And yesterday, we did talk about that polar air building up there in the Hudson Bay region. Let's see what's happening with that with today's GFS. Well, you can see that frontal system coming together there in Montana around Sunday to Monday. That's when we're looking for this to come together. And then by Tuesday and Wednesday, large front pushing down into much of the southern U.S. there. So here's some of the preliminary afternoon highs we're looking at next Wednesday. Lots of 60s and 50s there. And then overnight lows on Thursday, 40s and 50s. We shall see. The GFS is known to have a cold bias. On the other hand, we're coming within the 140 to 160 hour range. So as I said yesterday, there is going to be some truth to this solution, even if it's not quite as brutal as it's being forecast. But certainly this is going to be some unusual weather for mid-September. Usually we don't see stuff like this until around the 20th to 25th. So it's a good idea to cross-check things, and we'll do that with the European model. This starts out this morning, 12Z, and that shows a front coming out of the Dakotas, and we run that forward. And you can see the color shading kind of flip-flopping as we get the diurnal heating and the nighttime cooling. But up there in Alberta, Sunday, there it is coming together. Frontal system there. And it moves south into Montana Sunday morning. And then it looks like we have a bit of a intensification of the thermal gradient there late Sunday. And we see that coming together there and starting to surge down through the high plains. It looks like this even crosses the passes in Wyoming due to the sheer depth. So let's see, by Monday evening we got a rip-roaring front coming through Cheyenne and Denver and North Platte, and that surges south. This is pretty much a straight south to straight south-southwest trajectory. Don't see that too often. You can even see that coming in through Utah, and this is reminiscent of some of the big western outbreaks that we saw back in late 1990, where it just spills right over the western states. And I think we saw this in December of 2008 also, and there's probably been some cases more recently where this has happened. But yeah, you can see it heading there, the main thrust into New Mexico for Wednesday and into Texas on Thursday and Friday. Looks like it is slowing down before it gets to Texas. So this could be, in fact, the actual solution here. It really takes a lot to get 50s and 60s in Texas in mid-September. So, yeah, I hate to say it, but that may be the solution that we're looking at. But it looks like another surge coming in for Sunday to kind of reinforce things. And this one takes more of a southeast trajectory there. So again, this is looking at the 13th here. What's causing this pattern? We look at the 200 millibar chart. This is the GFS forecast up at the top of the tropopause. And we see a very deep northerly flow into the north central U.S. And we can also take a three-dimensional look at things. I'm going to go to Tropical Tidbits. They have a good model viewer. And if we take a look at things on Monday, where the system's coming together, I'm going to draw a line from around the Cambridge Bay area all the way down to Texas. Okay, so what we're seeing here, this is the potential temperature. This is basically temperature normalized to a common level. And we see the frontal boundary. I'm going to say that's probably it right there. I do see a gradient out ahead of it. That could be a little upper level front. So normally we want to see these surfaces flat, like back in here. That indicates a pretty homogeneous air mass. And the important changes occur where these surfaces are sloped. And where the surfaces are far apart, this indicates unstable air. Now we do have a jet up here. The component is going basically into the page. These velocities here, this is showing the motion to the left and right. But if you imagine this very fast motion here going this way from the poles, that's that northerly flow, and then it goes into the page right there. That's all part of the jet kind of arcing around and then going eastward. So underneath it we have unstable air with that strong upper level winds. That's going to give you mountain wave turbulence and kind of a rough ride in much of the southern plains if you're flying. Now the other thing I notice here is that there's quite a bit of depth to this cold air. This is the reason it's crossing the mountains out west according to the GFS. We also see the tropopause. There it is right there, around 300 millibars, and then it looks like maybe that kind of lifts up as we get into the warmer air down in the southern plains. So most likely we kind of have a fold going on there, the jet located right there, and then the higher tropopause out to the south. So anyway, tropicaltidbits.com, that's a good place to get some of these charts. And let me go ahead and show you that component of wind going into the page. There you go. Now you can really see that jet. This is a west to east jet right there. That's what I was kind of pointing out earlier. We don't see high velocities here because it's not moving into or out of the page. It's moving with the page and then feeding into this thing. So, it does require some three-dimensional visualization in your head as you use these charts. So this right here going into the page, that means in this little map inset that's very strong westerly winds blowing across the central plains. And you notice that it's right above this frontal surface. These jets feed off of those temperature gradients. Very strong temperature gradient right there, so the jet is found right overhead. So here's a very cool bonus chart. This is basically the same thing, the same cross-section, but we're looking at potential vorticity. That's indicated by the shading, so that's not wind speed anymore, that's potential vorticity, and the zero line indicated by this dashed black line. The purple lines that you see right here, that indicates wind speed. That's into or out of the chart, so, go back to that, it's the same thing. So we have a jet right here, and these surfaces of potential vorticity. Now what's important here is the jet cores are located right there, and we see these potential vorticity areas kind of wrapping around the north side like that. See, like that. That's that downward motion. You can kind of use potential vorticity to find where there is subsidence and ascent. Because as a layer tends to rise or fall, it tends to conserve the potential vorticity. Now this is different from the absolute vorticity you may remember off 500 millibar charts. Don't worry about that. That's kind of a different thing. This is something we use on cross sections. And a lot of times these potential vorticity drops can be very dramatic. And we call those tropospheric folds. So let's advance forward and see if we see a more dramatic example. Yeah, this looks like it's even more well developed. And this is such a strong indicator of downward motion that a lot of times research planes will fly into these folds and sample the ozone coming down out of the stratosphere. Sometimes that can come all the way down to the ground. That could be what's happening there. I'm not 100% sure. But in a very well-developed system, they can go downwards quite a bit. Starting out in the southeastern U.S., there's the patterns. Big old meso-high in East Texas associated with that MCS that moved through that area overnight. And there's the outflow boundary covering much of north and central Texas. Looks like our old frontal system is hung up in Pennsylvania off to the north side of the map. And then we got this new fresh front coming through the central plains. Behind that, temperatures in the 70s. And there's our satellite loop, the MCS moving through East Texas there. Looks like it's starting to subside, but we're seeing this new vigorous convection back there in central Texas around Junction to Fredericksburg. Looks like a few spots of convection also around Jasper to Fort Polk, Louisiana. Pretty quiet through much of the southeastern U.S., and then as we go to the north, we pick up increased convective activity with the jet stream running through that area, the new front approaching from the west, and unstable conditions in that area. Up to the north, things are certainly getting pretty dynamic. In fact, off the top part of the page, pretty intense system crossing Lake Superior there and starting to get some of that very strong cold air advection. That's the kind of cold air advection pattern that sunk the Edmund Fitzgerald almost 50 years ago. That happened out in this area right here. But it was a very similar pattern to this, maybe a little bit more stormy. But wow, look at those convective elements. That's going to be a very turbulent day in northern Wisconsin and the Michigan UP. And out ahead of it, we see the main baroclinic zone. That's going to be linked up with the front there, and then the so-called baroclinic leaf extending up to the north, up into Ontario. Looks like a little baroclinicity through Pennsylvania there. That would be indicated there by that mid and upper level cloud field, and that would probably be supporting that little weak front that's there in Pennsylvania. There's the mid-afternoon surface map in the northeast and Great Lakes area, showing a 983 millibar low up there in Ontario. Looks like that's up northwest of North Bay. Now, I did put that warm front pretty far up to the north. That may differ from some of the centrally analyzed charts, but what I went with is, you can see the air mass there, northern Indiana, upper 80s. And they taper off to like 81, 77 in Toronto, and it's still kind of retaining some of that warmth all the way up in Quebec. But when we cross over in the Canadian Shield region, whatever that is up there in northern Quebec, it falls off into 50s and 60s. So this appears to be the main transition zone up to the north. And then the system in the northeast U.S., that's kind of its own thing, the remnants of the old frontal system that went through that region. But back behind the new low there in Ontario, some very strong cold air advection, and a little cold air advection trough moving through Thunder Bay and Duluth at this time. Not much to say about the northwestern U.S. They're affected mostly by that ridge along the west coast. And we've got a surface ridge going all the way from the Vancouver area to Nebraska. So lots of fair weather, dry conditions, and a very slight northerly component through that region. The satellite picture pretty much reflects that. Only a little bit of mid-cloud. This is going to be patches of cirrus, a little bit of altocumulus there. You can see that little herringbone pattern. Mountain wave activity through there. It is kind of unstable back in that region. You got that cold over warm scenario with strong surface heating. And let's see, I thought I saw some smoke in here. No, that's cirrus. Okay, so that's about all there is to see in that part of the country. And then moving down south, it is pretty clear. Coming up on about 12 to 1 p.m. there in Arizona, and barely getting any convection. About the only activity is way back there in Texas, and I can see maybe a little bit of the cold front showing up there around Amarillo. And you might notice one thing I did here. Even though we have north winds in Lubbock, Midland, north of Fort Stockton, actually that's west of San Angelo. Anyway, these north winds here, I did not use that to place the cold front. A lot of inexperienced analysts, they might do something like that, to put the cold front there and then bring it up like that. You really have to use the thermal boundary. You can see we go from 94, that's hot, 94 hot, 90 is still pretty hot, and even in Amarillo, it's almost 90, but only there do we see the temperature start to drop. So that is the true location of the cold front. And another indicator there is the strong northwest winds there, gusting to 30 at Tucumcari, even though it's kind of hot there. That's an indication the front has just arrived. So, I might actually bring that back a little bit like that, or kind of like that. But that does have consistency with the satellite photo. You can see that linear cloud field coming together, plain as day, and back in New Mexico a little bit too dry to place anything. Placing those boundaries, that's very important. And let me just drop down to West Texas, see what's going on there. Do we see any boundaries there? Not really. I mean, there could be a little one right there. That looks like slightly more moist air there, drier air to the north. We can look at mesonet plots. You can put on your counties to kind of get your bearings there. So looking at the counties and transposing that, that's going to be right there. So do I see a difference in the air mass? It is really hard to tell. There's not very many stations out there, but this does look like kind of like a post-dry line air mass. It's very hot, dew point slightly depressed, and then out to the west we pick up the 60s dew points. So I don't know. Looking at this, there could be a dry line kind of going like that, maybe looping back. But with that 60-degree reading there, now that I see that, I might want to adjust the analysis a little bit, maybe pull that back a little bit. Okay, that's about all I got for this evening. Thank you for watching the webcast. I did see the latest round of Patreon donations hit, and I thank you very much for that. People like Robert Petit, James Taylor, Ron Chalfant, Philip Haley. I appreciate your support. It does mean a lot. And if you're not a supporter, keep in mind it takes me about 3 hours a day to put this together. So you're looking at about 15 hours a week. That's about 70 hours every month. So when you work out the numbers, yeah, I'm making less than minimum wage. I guess that's okay. It's supposed to be a fun educational project. But I've got to juggle that with about 6 or 7 other projects. So for the cost of a cup of coffee every month, this is how you can tell me to keep them coming. And at the same time, you'll be promoting good content on YouTube. And to sweeten the deal, new supporters in September, I'll enter you into a drawing to get a free copy of Instability, skew-t, and Hodograph Handbook. And if September is anything like August, we only had 3 new supporters, so your odds may be pretty good. But anyway, we'll find out in the first week of October. Okay, and that'll do it for me. Take care and have a great Thursday. Bye-bye.